Good evening, fellow scholars, yet again. This is me, Andrew Sperl, and this will be my second slideshow for my group. I wanted to make sure my group didn't fail, so I did 2 videos out of the 4 for our group. My next slideshow is compare data values from different sets using z-scores. And this is a presentation from Module 3 Statistics. Excuse me. Now, the creator of the z-score, his name is Edward. Creator of the z-scores, his name is Edward Altman. He is NYU Stern Finance professor. He developed the Altman z-score formula in 1967, and it was published in 1968. In 2012, he released an updated version called the Altman z-score Plus that one can use to evaluate public and private companies, manufacturing and non-manufacturing companies, and U.S. and non-U.S. companies. One can use the Altman z-score Plus to evaluate corporate credit risks. Now, how does z-scores work? Breaking down Altman z-score, one can calculate the Altman z-score as follows, which currently shows on the slide. Z-score equals 1.2a plus 1.4b plus 3.3c plus 0.6d plus 10e. Now the next is where? A equal working capital. Well, it's also total assets. Next, B equals retained earnings, total assets. C equals earnings before interest and tax, which is total assets. D equals market value of equity, which is the total liability. And E equals the sales and total assets. Now explaining the z-scores. What does a z-score tell us? A z-score describes the location of the raw score in terms of distance from the mean measured in standard deviations. It gives us information about the location of the score relative to the average deviation of all scores. A z-score is the number of standard deviations. Score is above or below the mean of the scores in the distribution. It is also a raw score, which is a regular score before it has been converted into a z-score. And the raw scores on very different variables can be converted into z-scores and directly compared. Now, what does a z-score represent? Which shows you right here on this slide. The z-score represents a raw score, but also represents a particular location along the x-axis of a distribution, which is this here. More extreme z-scores, the further it is from the mean. The percentage or area can be seen as representing probabilities of a certain score. Z-scores. Z-scores are used to standardize series and enable comparison mortality patterns between different populations or different time periods. Standard deviation is a unit of measurement of the z-score. It allows the comparison of observations from different normal distributions. In general, the z-score equals x mean of the population, standard deviation of the population, which can be approximated in our context by z-score equals the number of deaths, baseline, standard deviation of the residents, variation of the number of deaths around the baseline on the part of the series, used to fit the model used as a standard unit. Now, the z-scores are computed on a detrended and desynchronized series. After 2/3 of the power transformation according to the method described in Parrington's 1996, this enables the computation of z-scores for the series that originally Poisson distributed. And that is my slideshow for z-scores. One of the shortest slideshows I've ever done. I hope you all, you scholars, have a wonderful weekend, have a wonderful night, and I'll see you all on Monday.